All right, so I want to give you just a very brief, this is Newton's first law. Okay? So, does anybody know what Newton's first law actually says? I'm going to take that as a no.
An object at rest
An object that is set in motion is an equal and opposite.
Okay, so.
Stays in motion until something. Yeah. Oh, something like that.
Okay, so there's several. That's 2 or 3, I forget which.
Yeah.
The first one's the only one I care about today, which is the vector sum of the forces on an object is the mass times the acceleration on that object. So in this, acceleration's a vector because it's going to have a size, how hard is the thing accelerating, and a direction, which direction is it accelerating. You guys with me on that?
No.
Okay, so when you slam the brakes in your car, is it accelerating?
Yes.
Yes.
Yes, it's accelerating backwards.
Oh, okay.
You guys see that? When you slam the gas, right, it's accelerating
Forward.
wherever it's pointed, right, forward. So that's why this thing has a vector hat on it, because it contains not only the how hard is this acceleration, like how much is this slamming you into your seat, but it also contains the which direction is that pointed in. You guys cool with that?
Say the words of the function again.
Yeah. So the vector sum of the forces on an object is the mass of the object times the acceleration vector. So what that says is if you add up all the forces in a vector way, you get out a vector that tells you which direction this thing's going to go and how fast with this kind of factor of the mass. You guys cool with that? So let me give you the dumbest possible example. Here's the ground. Here are you. Here you are. I'm going to consider you to be one object collapsed to your mass at your belly button. Okay? So think about yourself as a very small sphere with your same mass. Don't think about what this process did to you. Don't worry about that. What's the force acting on you?
Gravity.
Gravity? So that's force of gravity, right? That's an arrow. It's got a direction and a size, right? How hard does gravity pull on you?
9.40%.
Okay, so you guys apparently know this is 9.8 meters per second squared.
Meters per second.
Okay, that's the acceleration due to gravity. So how much do you weigh? Okay, so let's put it in kilograms and get over our hurt feelings. So we'll just call it 60 kilos, which for some of you, yeah, don't think about this. Don't worry, it's in kilograms. That doesn't mean anything. So right now I have here an acceleration speed due to gravity, a mass. So this is kind of a force. I need the direction information. So where is this thing pointing?
Down.
Down. So this is in the minus j direction. You guys all with me on that? How fast are you accelerating right now?
In relation to the
Are we?
Yeah, I'm not moving, right? And I'm not starting to move. You forget the fact that Earth is spinning around the sun and all that jazz. An inertial frame of reference or something. Yes. You don't need that. Just right here, am I accelerating?
No. Yeah. You have to come both directions. Gravity.
Oh, that's cool. Yeah. So I'm not accelerating, right? So my vector sum is 0. You guys see that? So for objects not moving or not accelerating, right? And really those are slightly different. You guys recognize that? So for objects not accelerating, the sum of the vector forces is 0, right? Because the acceleration vector is 0.
Okay, so I can say that I weigh nothing.
No, this doesn't say you weigh nothing, right? Your mass is still in there. It's just multiplied by the 0 vector. You guys see that? So what is the counteracting force? There's a force of gravity. That's got these numbers that we just said. Where's the other force?
It's the ground pushing back on you.
Oh yeah, the ground pushes back on me. And how hard does it push back on me?
Exactly.
9.8 times 60
J.
J's, right? You guys see that? The dumbest possible example is I'm standing on the ground, my vector sum has to be 0, so I know that there's a gravitational force. This other one is what? You guys know a symbol for that?
Subscript N.
Yeah, that's usually described as a normal force. So there's a force of gravity, right? That's pulling me down. And then there's a normal force, that's the floor pushing back. You guys cool with this? All right, so this was as simple as it gets. You want to do a slightly harder one?
Sure.